Hello everyone, welcome back to my channel. So first of all, thank you for everyone who subscribed, so that now the number of subscribers has reached 500, so that we can actually release this video here. And also thank you for everyone who watched my videos. So as promised, once when this channel hits 500 subscribers, we'll have a series of 100 problems of factoring, and this series is going to last until we hit 1000 subscribers. So my plan is to release a video every time when there are 50 more subscribers actually subscribe to this channel. So the next video of this series is going to be released once there are 550 subscribers. Anyway, so today we will actually start the first video of factoring polynomials of degree 2 or higher, and we are going to start from something very basic, which is starting from quadratic forms, and we're going to move on as we move to the future videos. So here we go. First, we have this problem here, a squared minus b squared. So this is a start off of what we need to learn how to factorize a quadratic expression. And sometimes we have to memorize some of the formulas so that it will be very easy and it will turn out very convenient to factor out something. So this is one of the formulas we definitely need to do. So what do? Well, to factor this out without knowing the formula, what should we actually do? Well, here is the trick. We're going to add a zero, a fancy zero, such that we'll be able to do factoring. In this case, we're going to add a AB and then subtract a AB at the same time. So that in factoring, one of the easiest method is doing grouping. As we have 4 terms here, we can actually try to group it by 2. In other words, we can actually group these 2 together, and then we're going to factor out something in common. In this case, we see that there's an A here and there's an A here. So we can factor out the A so that we have A plus B remaining. Then after that, for the other 2 terms, we can factor out the negative and the B so that we get A plus B. Then we're going to factor out again to get A minus B times A plus B. Okay. Second problem, we are going to try to use the formula that we just got to factor out the following problems. So in this case, what is our A? It will just be X here. And what is our B? Our B is just 1. And since 1 is actually the same as 1 squared, we can just think that our B is just 1 itself. So that now, as we factor out, we get x minus 1 times x plus 1. Okay. So another problem or another example is the following. So how do we do it? Again, we have x squared, so our A will be x. Then minus 100, what is the square root of 100? Well, it is 10. So we will just factor it out as x minus 10 times x plus 10. Okay. Next one. So again, we have x squared, so we will just let our A be x, and then minus 25, which is 5 squared. So what is our B? It will be 5. Now you may ask, what happens if we try to choose the b as -5 instead of +5? We can actually see what's going to happen. In this case, we'll have x as our a minus b, where b in this case will be -5, and then times a plus b here. Then if we try to simplify each bracket, we'll end up with x plus 5 times x minus 5. And in fact, it is actually the same as if we set our b as +5, because we will just get x minus 5 times x plus 5 back, and the result was not going to change, as we know that when these two multiplies together, we'll get the same results back. And we call this commutative, meaning that we can have the first term times the second term is the same as the second term times the first term. Okay. So next we're going to do another problem as our warm-up. So again, we have x squared minus 64. What is our a? Our a will just be x here. And what's our b? Well, if we say 64 is b squared, then we have b is just the square root of 64, which is 8. Then we'll get x minus 8 times x plus 8. And that is it. So why do I have to do these easy problems as part of the exercise problems? Well, first of all, it's someone who actually requests me to do the series of the videos of factorizing quadratic terms. So I might as well just set up something start something easy in our setup. So that, no, this is a 1 here, so that we can actually try to get used to something easy before we move on to the next step and trying to do something a little bit more challenging. And also, this might actually encourage some of students, maybe high school students or middle school students who are still barely learning algebra and learning how to do factorization. So hopefully the series of the videos will be able to help them understand how to factorize in a better way and a faster way. So now we're at problem 6. We're going to make something a little bit more challenging. So instead of just starting off with x squared, we now have some constant times x squared here. So that when we try to consider what our a is, we need to think about what we need to do instead of just simply calling our a as just x. So in this case, if we say our first term is a squared, then what is the square root of 4x squared? It will just be 2x quantity squared. So similarly, for our b, we have 121 squared. Well, the b squared is 121, so our b will just be 11 squared. So as we try to factor out, we will just get 2x minus 11 times 2x plus 11. Okay, next we're going to look at this problem here. Number 7. It will just be 4x squared minus 1. So in this case, what is our a? Well, it will be the square root of 4x squared. And again, it doesn't matter whether or not we choose positive or negative. In this case, we can see what happens if we choose negative. So in this case, we can say that the square root, the negative square root, or the square roots that contains a negative sign of 4x squared will just be negative 2x. Then for b squared, well, since b squared is 1, in other words, we have our b to be positive or negative 1. So let's say if we stick with positive, then as we factor out, we get negative 2x minus 1 times negative 2x plus 1. Then it could look a little bit different from usual, but we can actually try to factor out the negative in each parentheses and see what's going to happen. If we try to factor a negative from this term, we have to flip the sign of all the terms inside. So we end up with 2x plus 1. And of course, in this case, since we already factored out the negative, we have to put a negative in the front. Then we'll have the other term. As we factor out the negative, we end up with positive 2x. And instead of plus, we will change it to minus 1. Then as we try to multiply these two together, the two negatives will cancel out, so that our answer will just turn into what we usually expect, which is positive 2x plus 1 times 2x minus 1, like that. Okay, then next we have this. (9x squared minus 289). So how do we do it? Again, our a would just be the square root of 9x squared, which is 3x. So again, that's just saying that 3x times 3x gives us 9x squared. How do we know? Well, we will just take the square root of 9 and then times the square root of x squared, which is one of the properties of radicals. Then we actually get 3 times x. Then what is our b? Well, b squared will be 289. And what is the square root of 289? Is 17 here. So, as we factor out using the formula, we get 3x minus 17 times 3x plus 17. Okay, next one. Number 9. We have 9x squared plus 100. So in this case, what do we do? Well, let's take a look. If we want to say find out our a squared and b squared respectively, of course we can just say that this the first one is a squared, which will give us 3x quantity squared, where b's would just be the square root of 100, which is 10 here, so that we will say that b squared is just 10 squared, which is 100. Then we're going to factor it out and say that we have 3x minus 10, which is again a minus b, times 3x plus 10, a plus b. That's it? No. This one is a trick question. At least for high school level or middle school level algebra class, this is not how we should factor out, and this is a mistake that a lot of students will make. In fact, for high school level or middle school level algebra class, we will say that this is not factorable. Here is a reason. First of all, how does this give us a mistake? Why is this not correct? Well, remember at the beginning in our first problem, we're saying that the result is a minus b times a plus b. But what is this product here? Which is what is the question in problem A? It is actually the expression a squared minus b squared. So be careful. In this problem, we actually have a plus sign instead of a minus sign. In this case, we will not be able to factor out. In fact, when we have a squared plus b squared, we're of course assuming that both a and b are a squared and b squared are of course positive numbers. We will say that there's no way we can factor out if both terms are actually in degree 2. In other words, if we we just have square here. Okay, so in fact there is no answer, or we will say that this is not factorable for this one. Okay, so in this video we'll actually see a few of we'll actually see some counter examples such as this one that looks similar to other examples problems, but in fact they are not factorable in our level the level that like the beginning level of in algebra. So next one we have 25x squared minus 4y squared. So again, what do? If we set our first term being a squared, then the a would be the square root of it, which is 5x. Similarly, our b squared would then be 2y here. And now, don't forget we need to make sure we need to check the sign here. This is a negative sign. So, what's the answer? It would just be a squared, a minus b times a plus b, and that's it. Problem 11. We now have something a little bit trickier. So we have 2x squared minus 18. If we're trying to use the formula saying that this is a squared minus b squared, let's see what happened. If we try to set this as a squared, we're going to get something square is equal to 2x squared. Well, of course, we have the square of x is x squared. But then what should we fill in here? Do we have any whole numbers that can actually do that? Well, actually there isn't, because what is the square root of 2? Is that an integer? Not really. And in fact, if we look at the other term, do we actually get the square root of 18 an integer? Not even. So what should we do? Well, in this case, we can try to factor out something in common first. So between 2x squared and 18, we see that both 2 and 8 are even numbers. In other words, they're divisible by 2, or they're multiples of 2. So what are we going to do? We're going to factor out the 2 and then see what is remaining inside. So as we factor out the 2, the first term will now turn into just x squared minus the second term, which is half of 18, or 18 divided by 2, which is 9. So now if we look at everything inside parentheses and set it as a squared minus b squared, we'll be able to find out that our a is just simply x, and our b would just be square root of 9, which is 3. Meaning we now can factor one more time by using the formula that we started off at the beginning. We actually get x minus 3 times x plus 3. And don't forget, we still need to leave the constant or the coefficients out, okay? So this is the final answer for factoring out something that does not start off in a squared minus b squared. Okay, next one. Number 12. We have 3x squared minus 12. So again, if we look at this here, clearly 3 is not a square number. It's not a perfect square. So in fact, we can try to factor the 3 on both terms to give us x squared minus 4 remaining. And 4 is just 2 squared. So we can factor it out as 3 times a, which is x, minus b, which is 2, times a plus b, which is x plus 2. That's it. Okay. Number 13. We have 7x squared minus 343. So if we see this, again, we have a 7 here, which is not a perfect square. We might as well try to see if we can factor out this 7 so that we will leave the first term into x squared. Then to do that, we need to make sure that the second term here is also a multiple of 7, otherwise we cannot factor out. But 343 is in fact equal to 7 to the third power, meaning if we try to factor out the 7, for the first term, we end up with just x squared minus the second term. As we factor out 1 copy of 7, we have 2 copies left. So now we actually have the form of a squared minus b squared, where our a is of course x and our b is just simply 7 here. So we can try to factor out once more to get a minus b times a plus b, where a is our x and b is our 7. So our final answer will just be here, this expression here, 7 times the quantity x minus 7 times the other quantity x plus 7. Okay, number 14. So for problem 14, we have 5x squared minus 80. So again, the first step, we can try to factor out as the leading coefficients 5 here, and so that we can turn our first term into simply a squared, a perfect square. Then as we factor out, of course, we end up with x squared for the first term. And then for the second term, we have 16 left. But what is 16? 16 is just the square of 4. So in other words, we have x squared minus 4 squared inside of the parentheses. So we can use the formula to get x minus 4 times x plus 4. And then don't forget we have the times 5 at the beginning. Okay. Problem 15. We have 6x squared minus 54. So again, 6 is not a perfect square. So we will try, we need to factor out the 6 if possible. And hopefully, so that we will be able to return, we of course will turn the first term into just simply x squared, which is a perfect square, and hopefully turn the second term into a perfect square as well. So we end up with 6 times the quantity x squared minus, what is 54 divided by 6? 9. But what is 9 a perfect square? Yes, because 9 is same as 3 squared, or 3 times 3. So in this case, our b would just be 3 here. so that as we factor out using the formula, we get 6 times the quantity x minus 3 times the quantity x plus 3. Problem 16. We have this here this time. We have negative x squared plus 36. So now let's take a look. In problem 9, we just said that we need to be very careful on the sign, right? If we have a positive sign, we will not be able to factor out, because if we have a squared plus b squared, we do not end up with the same result as a squared minus b squared, which is factorable. So does that mean this expression is not factorable? We actually see that in this case, even though there's a plus sign here, we also need to consider that the x squared term, or the first term, has a negative sign. So in fact, we should actually factor out the negative sign first, so that we will see what sign we get for the second term. In this case, as we factor out this negative, the first term is of course turning into positive of whatever we have. In this case, it will be x squared. Then for the second term, as we factor out the negative sign, it means that we had to do a sign change, or flip the sign. So instead of having a plus sign, we need to change it into a negative sign, or a minus sign. So now inside of the parentheses, or everything inside of the parentheses, we have a squared minus b squared, so that we are actually be able to factor out using the formula. So in this case, what is our b? B is just the square root of 36, and 36 is a perfect square because it is equal to 6 times 6, or 6 squared. So in this case, our b will just be 6. So as we factor out using the formula, we get x minus 6 times x plus 6. And don't forget there's a negative at the beginning. So in fact, this expression, even though there is a positive sign or a plus sign before the second term, it is still factorable because we actually have a negative sign. So in fact, for the formula that we have, a squared minus b squared is factorable. We can also think it the other way by rearranging the two terms. So we'll just put the minus b squared in the front, and then the a squared, which is a positive, to the back, and rewrite it as negative b squared plus a squared. And in this case, we will say that a and b are what we call dummy variables, meaning that they are just placeholders in some sense, because a and b could be anything if we want to plug in any numbers. So in this case, we see that a and b are actually playing the same role. So as we rewrite it into this step here, we can see that it's not always necessary to have the second term having a negative. It's more important that the two terms are having different signs. One must be positive, one must be negative, or you can think it as one is plus, one is minus. And in this case, it actually satisfies that the first term is negative, the other term is positive. They have different signs, so that we will be able to factor out using the formula. Okay, so next we're moving on to problem 17. So problem 17 is negative 3x squared plus 27. So again, we have negative 3 here. We need to factor it out. We need to factor the negative to turn the first term into positive, as well as factoring out the 3 because 3 is not a perfect square. so that as we factor out, the first term will just be x squared. So we have x squared remaining. And clearly, this is a perfect square because it's just a square of x. Then, as we factor out -3, the second term will first have the sign change. It turns into negative. And then factor out the 3, so we end up with 27/3, which is 9. But what's 9? 9 is just 3 times 3, or 3 squared. So we can rewrite as 3 to the second power. So that now we have a squared minus b squared form. And we can now try to factor out once more using the formula that we know to get x minus 3 times x plus 3. And that's it. Alright, problem 18. So problem 18 is the following. -12 x squared plus 3. So again, what should we do? We definitely need to factor out the negative sign here so that it will turn into positive. Then 12 is not a perfect square. What should we do? Should we factor out a 12? Yes, we can do that, but it's not necessary to do that either, because we can rewrite 12 as 3 times 4. Well, of course, the 3 is not a perfect square. We need to factor out. But 4 is a perfect square. So in fact, we can just simply factor the 3 here. And then keep the 4 with the x squared. So in this case, we end up with -3 times. The first term will become 4x squared. And then for a second term, as we factor out the -3, we need to change the sign, and then 3/3 is 1, so we have -1 here. So in fact, now as we factor out this way, we still end up with the form a squared minus b squared, where of course in this case our a squared will become the square of 2x. So if we use the formula, we get -3 times the quantity 2x minus 1 times 2x plus 1. And that is our answer. Okay. Problem number 19. We have -x squared minus 144. So let's see. We have a negative sign here. Good. So we have x squared and then 144. So of course x squared is just the square of x. 144 is the square of 12. So what should we do? Factor it out, right? So that we set our a is x, b is 12. We get x squared. No, we get, if we factor out, we get x minus 12 times x plus 12. Right? No, because we actually have a negative sign. Again, if we have a negative sign, one way of seeing it is we can factor it out. Another way to see to check is if they have the same sign for both terms. So if we have a negative in the first term, we do not want a negative in the second term. We need to have a positive sign in order to factor out or use the formula. If we check it with the first way, this is what happened. As we factor out the negative to turn the to make the first term positive, we get negative factor out. The first term will become, of course, still x squared. But then for the second term, we still have 144. But since we factor the negative, we need to flip the sign. So the negative will turn into positive here. And once again, we now have a squared plus b squared, which is not factorable. So, in fact, this expression or this quadratic expression is not factorable, meaning that if we after we factor the negative sign, everything inside cannot be decomposed into two smaller terms. Now you might say that, well, we have a negative sign, how is it not factorable? So it depends how what you mean by factoring. If you consider taking out the negative sign as part of factorization, yes, it is factorable. But if you move up to a higher level of algebra class, you will figure out that we usually don't consider taking out the negative sign or even taking out some of the constant terms or numbers as part of factoring. If we are factoring polynomials or with variables in higher degrees. When we say factorable, usually we mean that as we decompose the expression, the degree must getting smaller than what we start off. So in this case, we actually have a degree 2, but as we factor out at the end, we still end up with a degree 2 here, meaning that we still end up having a quadratic expression. So we didn't really do much to the original expression. Anyway, that is the answer of problem 19. So next we have problem 20, which is negative 6x squared plus 150. Again, since we start with negative in the first term, we should factor out first so that we end up with positive a squared, and then we will see whether or not we have a negative sign for a second term. And we also have a 6 here, which is not a perfect square. In fact, it's just 2 times 3. We might as well just factor out the whole thing, 6, so that now the remaining part will just simply be x squared. Then hopefully as we factor out negative 6, the second term will turn into a perfect square as well. With the sign change here, we actually end up with negative, which is what we hope in order to use the formula. Then factor out of 6, we have 150 divided by 6, which is just 25. But what is 25? 25 is in fact a perfect square is the square of 5. So we will rewrite it as 5 squared. So now we have the form a squared minus b squared inside of the parentheses. We can actually do the factorization using the formula that we know, which means we now have a minus b times a plus b, where in this case our a will be x and our b will be 5. And that is the answer. So, next problem. Let's see. We have something that comes a little bit tricky. So this time we have a fourth power. Actually, we have fourth power for both terms. But in our formula, we only have the second power for both terms. We have a squared minus b squared, or a to the second power minus b to the second power. So what should we do? Well, when we think something, when we have a fourth power, what does it really mean is that we actually have 4 copies multiplying together. So x to the fourth power means that we have x times x times x times x. Then how can we rewrite it into something square? Well, square means that it has something times itself. In other words, how do we actually break it into 2 groups so that each group has the same amount of x? In this case, we can just break it like this. We'll group 2 x's together so that each group will actually turn into x squared. And then we have x squared times x squared. So In fact, you can use the exponent law to find out how to break it into something square by dividing the exponent into by 2. So in this case, x squared is just the same as, no, x to the 4th power is just the same as x squared squared. Similarly, y to the 4th power is same as y squared squared. So if we use our formula, we will actually get our a is x squared minus our b, which is y squared in this case, times, of course, we have x squared plus y squared, a plus b here. So are we done? Well, let's double check. For the second part, we have a plus b, which is x squared plus y squared. It doesn't look like anything that we know of. And in fact, it actually looks like something that we know of that is not factorable, because this is a plus sign. They actually share the same sign. We have we have x squared, which is looks like a squared, and then we have y squared, which looks like b squared. So this part is actually done. There's no more factoring. Okay, because again, it's something that we already discovered in the last couple problems. But now we need to go back and check our first factor. We have x squared minus y squared. Of course, it looks like a squared minus b squared, right? Where our a is just x and b is just y in this case. Meaning, we actually need to, we actually can factor this out one more time. And in fact, we'll actually, we actually need to factor out, since this is what we're trying to do. Then in this case, we'll actually get a minus b, or x minus y, times a plus b, which is x plus y, as we factor out this term here. Then of course, don't forget to copy this down, which is a mistake of a lot of students usually will do at the beginning, especially for students that I know of. So remember, just bring everything down if we are not touching it, okay? So this will be our final answer for this problem. Number 22. We have x to the 5th power minus x. So now, look, we actually don't have an even power. We have an odd power. What should we do? Well, we see an x here, we see an x here. So why don't we just factor out the x and see what's going to happen? If we factor out the x, we have one x left. We have one x less. So instead of having 5 copies, we take out 1 copy. So we end up with only 4 copies left. We have x to the 4th power for first term. And how about the second term? Well, we solve with only x, meaning that we only have 1 copy. If we factor out the only copy, the only way that we can fill in is 1. Remember, it is not 0, but 1. Because in order to multiply 1 copy to get itself back, the only thing that we can put is 1. 1 times whatever, 1 times x is equal to x. Okay. If we put a 0, we actually get a different result. Because if we put a 0 here, multiply with x, it is still 0 instead of an x here. So, as we move on, we can see that this here is something that is related to our previous problem, because we have an x to the 4th power minus 1, but 1 is just 1 to any of the power you want. So in this case, we can rewrite 1 as 1 to the 4th power. And now we actually have something similar to x to the 4th power minus y to the 4th power. Well, in this case, our y is just 1. So we can just try to factor out using the results that we got from previous problem. This is all doing in 2 steps. to get that, we have x minus y. In this case, it will be our 1 times x plus y, or 1 in this case, times x squared plus y squared, where again our y is 1, so the square of it is still 1. And that will be the final answer of this problem. Alright, good. So 23. We have u to the 4th power minus 4. So we see that we have a 4th power here, right? Then can we use the results from problem 21 to help us, so that we can skip all the steps if possible? Well, let's see. Is 4 a power of 4? Is a number of 4th power, where the number is an integer? Not really, because if we think of the charts, let's say we're doing it like this, n and raise it to the 4th power. We know that 0 to the 4th power is 0. 1 to the 4th power is still 1. But 2 to the 4th power is actually saying that we have 4 copies of 2 multiplying, which in fact will give us 16 here. So in this case, we actually see that 4 is not a 4th power of any whole numbers or integers. So we cannot use the results from the problem 21 to and apply it into this problem here. Then what should we do? Should we just give up? Well, don't forget that if we have something to the 4th power, that 4th power can also be rewritten as the 2nd power, or squared. And at the same time, we also need to check that if 4 is also a square of some integers. It is, because 2 times 2 is 4, or 2 to the 2nd power is 4. So in fact, 4 is a perfect square. And we just said it, if we have the 4th power, we can rewrite as 2nd power to the 2nd power. So this is the same as u squared to the 2nd power. So if we try to factor out, our a will just become u squared, and then minus b, which is 2 times our a plus b. And that's it. And again, we can check that for a second term, we have the same sign. We don't know how to factor out. We cannot factor out anyway. For the first term, we have u squared minus 2. Well, clearly the first term is a perfect square. But the second term, 2, is not a perfect square. We cannot use our formula. So that will be the final answer. Problem 24. We have negative 3 times t to the 4th power plus 243. So again, since either way, we need to put the first term into something to 4th power, or even worse, we still need to put it into the 2nd power. But clearly, negative, we need to factor out the negative in order to make it positive. And the 3 is not even a perfect square. We need to factor out in order to make the first term into a perfect square in minimum. Then if we do that, our first term is of course going to be t to the 4th power after we factor out the negative 3. And for our second term, we need to flip the sign as we factor out the negative. So the plus sign will turn into minus. And then 243 divided by 3 is 81. But now, what is 81? Of course, it is just a square of 9. But what is square of 9? Well, it is actually the same as, well, we know that 9 is also a perfect square. So it is in fact 3 squared. So this is the same as 3 squared. So in fact, if we use the exponent rule, we can just multiply the exponents together. So 2 times 2 is equal to 4. So in fact, we end up with something to the 4th power minus something to the 4th power, which is same as the expression in problem 21. So we can just apply the results into here by setting our x be t and then our y be 3. So we have -3 times the quantity t minus 3 times t plus 3 times t squared plus 3 squared. And last but not least, we need to simplify what 3 squared is. And 3 squared is again equal to 3 times 3, which is 9, as we already said at the beginning. So our final results will be here. -3 times t minus 3 times t plus 3 times t squared plus 9. And that's how we factor out some complicated expressions like this that actually has only 2 terms. Okay, problem 25. We have x to the 4th power plus z to the 4th power. So should we just use the results from problem 21? No, because we don't end up with a negative sign here. We have the same sign. This is a positive, and then the second term is also positive. And in fact, can we even use our formula from problem 1? We cannot even use that because, again, they have the same sign. Even if we try to rewrite as the first term as x squared and then the second term as z squared, we cannot apply the difference of squares formula, which is actually the name of the results in problem 1, into this problem, because again, it requires different sign between the 2 terms. But since they have the same sign, we cannot use it. And in the results, this expression is not factorable. At least based on our standard, that we want everything in whole numbers or integers, coefficients. Okay, so we're actually finished a quarter of the problem set. Next, we're moving on to problem 26, and we'll start off with something different. Instead of having only 2 terms in our expression, which becomes which we call quadratic binomials, meaning that there are the highest degree is 2, or you can say a second power in the expression, but there are only 2 terms. Now we are actually having a trinomial here, but this trinomial is also something that students need to memorize in algebra class. In fact, we have a squared plus 2ab plus b squared. So if you know the results, great. But do you know how we actually get the results? Don't say that we are trying to do it backwardly and find out. Of course, if we do it that way, it will be a lot easier to get what we need. But if we don't even know that result? How could we even get that? Here is the trick. Remember, similar to problem 1, if we try to do factoring, we would like to use grouping method, meaning if we have only 2 terms or 3 terms or whatever, we would like to group it into 4 terms or maybe 6 terms, some numbers of terms that are actually not prime, so that we can try to put them in groups of same amount of terms in several groups, and then try to see if there's anything factor out, and then there's something in common later on. What does that mean? It means that now we can actually try to rewrite one of the terms into 2 terms. So in this case, we're going to break the 2ab into simply just ab plus ab, meaning that it's adding itself, and start grouping. So we can actually group the first 2 terms together and then the second 2 terms together, such that as we group the first 2 terms, we can actually see that there's an a here and there's an a here. We'll factor out the a, and for the remaining parts, after we factor out, we'll just get a squared becomes a, as we take take 1 copy out of 2, we only have 1 copy left. And then for ab, as we factor out the a or divide it by a, we actually just have the b remaining. Similarly, for here, we can factor out the b that's in common, such that as we factor out, we have simply a remaining plus factor out 1 copy, we still have 1 copy remaining b. And now we have a plus b and a plus b in common. We can just factor that out and see what is in what are remaining. So for the first term, we have this a here, and then for the second term, we have only b here. And now we are almost done. But since these 2 are actually identical, a plus b and a plus b, we might as well just put them together by saying that we're multiplying 2 copies of a plus b, meaning that we'll just put it as a second power. And that's the result of 26. Okay. Next, we're going to try to see examples of the form a squared plus 2ab plus b squared, and use this formula here. The formula which named as the square of the sum. So in this case, we have q squared plus 2q plus 1. So now we need to be a little bit careful, because as we need to identify what our a and b are, we also need to make sure that the term in the middle here will actually contains 2, is actually the same as 2ab. In other words, we need to make sure that this product is going to is actually correct. So let's see. If we say that the first term is a squared, then our a is just simply q, and of course squared. And then for the last term, if we say it as b squared, we have our b is just 1 and then squared. And again, that's because 1 to the second power is just equal to 1. Then as we identify what our a and b are, what we need to do is make sure that for the middle term here, it is actually equal to 2 times a times b. Well, if we plug in what our a and b are that we assume, we have a is q, b is 1. Then as we multiply it, this is equal to 2 times q, which is 2q, times 1. Again, it's not going to change the 2q. So the end result is 2q. Meaning that now we actually have the middle term correct. So in results, if we try to, we can actually try to use the formula to factor out this trinomial expression. And again, the prefix trie means there are 3, okay, in this polynomial. Then it has 3 terms here. We call it trinomial. So if we use the formula, we'll actually have a plus b quantity squared. So it will be q plus 1 quantity squared for this problem. Okay, number 28. We have w plus 10 w squared plus 10w plus 25. So if we try to use the formula, we have a as w, b is the square of 5. Well, b squared is the 25, which is a square of 5. So our b is just 5. Then for the middle term here, we need to check. If we assume that a is w and b is 5, then 2ab will just be 2 times w times 5, which is equal to 2w times 5, which is 10w. Is that what we have here? Yes, it actually matches. So we can actually use the formula. So if we use the formula, we get a plus b quantity squared, w plus 5 squared. And that is our answer. Okay, 29. Y squared plus 6y plus 9. So is it factorable? And can we use the formula? Let's see. Well, we have clearly is a perfect square. Our x is just y now. And then our y in the formula will just be the square root of 9, which is just 3 squared. Again, 3 squared is equal to 9. Then the thing that we need to check is if we multiply those two assumptions here, y and 3, and then times 2, does that give us a 6y? Yes, it does, because 2 times 3 is 6, times y is just 6y. We just put them all together. So it actually matches. So we can use the formula, and if we use the formula, we just simply have y plus 3 quantity squared. Okay. So problem 30. (4t squared plus 4t plus 1). So this time we don't have something that is x squared or y squared anymore. This time we have a leading coefficient. But again, we can rewrite. We know that 4 is a perfect square, so we in fact know that this whole thing is also a perfect square. We can rewrite it as 2t quantity squared, and again, that's because 2 is the square root of 4, so we just factor out and put it back with the t. And then again, 1 is the same as 1 squared here. So our last thing to check is if we put these together and multiply with another 2, meaning that with 2, when we have 2ab here, do we actually get the middle term that we have? Well, let's see. We have 2 times 2t, which is 4t, times 1 is still 4t. So it matches. So if we factor out, we have 2t using the formula. We have a plus b, which is 1 here, quantity squared. So we actually get that if we factor out, we have 2t plus 1 quantity squared. It is factorable. Okay.